Alright, so in this video, we're going to be doing some more cross-product practice, okay? This will be the part 2 video. So, we want to determine the area of a triangle formed by these 3 points. 1, 2, 3, negative 2, negative 3, negative 4, and 1, 1, 1. Okay? Now this would be pretty easy if we were just talking about something in 2 dimensions, but now that we're talking about something in 3 dimensions, well, it gets a little bit more tricky. Okay, and we need to remember that the area of a triangle is equal to 1/2 times the cross product. Okay, the magnitude of the cross product, rather. Okay, so how do we, well, with the cross product, we're talking about vectors. Okay, so we have 3 points here. We need to find 2 vectors out of that. Okay, so this is not going to be accurate at all, but let's say we have 3 points. It's basically what we have: P, Q, and R. Okay, what we're going to do is just find this vector, okay, and we're going to find this vector right here. Okay, and that will be our vectors A and B. Now when we take the cross product of these 2 vectors, A cross B, okay, we're going to get a vector that, in this case, when we do right-hand rule or we twist a screwdriver from A to B, we're going to get a vector that points out of the board. Okay, it's going to point out of the board, and not that that really matters for this problem, but the length of that vector, okay, the length of that vector is going to be 2 times the area of a triangle, so we divide by 2 on both sides, and we get that the area of a triangle is equal to this. Okay, so that's kind of what we're doing here, and I talked more about that in the explanation video. So, we need to find vector A and vector B. Vector A is going to be that vector from point P to point R. So let's say, well, point P is 1, 2, 3, point R is 1, 1, 1. So we're going to have the vector, it'll be 1 minus 1, comma 1 minus 2, comma 1 minus 3. Okay, that will be vector A. And, well, that's going to equal, that'll just be 0, negative 1, negative 2. Okay, and for vector B, that's from P to Q, and we'll have a negative 2 minus 1, so that's going to be negative 3. We'll have a negative 3 minus negative 2, okay, and that's going to be negative 1. All right, and then we will have a negative 4 minus 3, and that's going to be negative 7. And for vector B here, we're going to have a, well, that's the distance from, we're going to talk about the vector from P to Q. So we have a negative 2 minus 1, that's going to be negative 3. We have a negative 3 minus 2, which is a negative 5. And we have a negative 4 minus 3, that's going to be negative 7. So now we have these 2 vectors, and we're going to find the cross product of them. Okay, so over here, we will have 0, negative 1, negative 2, and we're going to cross that with negative 3, negative 5, negative 7. Okay? So, now let's do the cross product. We need to find the determinant of our 3 by 3 matrix. We have, for our second line, 0, negative 1, negative 2, and for our third line, negative 3, negative 5, negative 7. Okay, so we have equals, we're going to have I hat times negative 1 times negative 7 is 7. We're going to have minus a negative 5 times negative 2, that's going to be 10, so we're subtracting 10. Minus j hat. We have a 0 times negative 7, which is going to be 0, minus a negative 3 times negative 2 is going to be 6. Then we have plus k hat. 0 times negative 5, that's 0. And then we have a negative 1 times negative 3, and that's going to be 3. So we're going to have a minus 3. Okay, now this is going to be equal to, we're going to have a negative 3 I hat minus a, well, we have negative 6 j hat, so that's going to be plus 6 j hat. And then we have a minus 3 k hat. So we're going to get the vector. Okay, we'll get the vector, well, this is our vector, but we're going to write it in angle brackets form here. -3, 6, -3. Now that is, right there, that is equal to, not the magnitude, it's equal to A cross B. So if we want to find the magnitude of A cross B, which is what we need for our formula, we find the sum of the squares and then we square root that. Okay, that's our distance formula. Okay, so we're going to have the square root of the sum of the squares, the sum of the, well, we have squares, so -3 squared plus 6 squared plus -3 squared. Okay, if it's confusing you how I'm saying the sum of the squares, we're taking the sum, finding the sum of these squares. Okay, so that was actually something that did confuse me at first, so I want to clarify that. And then we're taking the square root of that. And you see that a lot more in physics, so I had to deal with that quite a bit. Now, this equals, we have 9 plus 36 plus 9, okay, which is equal to 36 plus 18, which is rad 54. Okay, so now we have rad 54, but we want to find 1/2 the magnitude of A cross B. So we want to have A cross B magnitude over 2, which is now going to be equal to rad 54 over 2. And there you go. That is the area of your triangle. Okay, so really, we first started out by, well, not that this is an accurate diagram or anything, but I gave you an idea of what we're doing. We found vector A and vector B. Okay, and that can be from any point you could have done that. It doesn't have to be from point P. But then once we found those vectors, we just took the cross product, or we found the cross product of them, and we, well, divided that by 2 after we found the magnitude, and we got the area of a triangle. Okay, if you're finding the area of a parallelogram, which is another thing you may be asked, well, then you're not dividing by 2. Okay, because the area of a parallelogram is just equal to the magnitude of A cross B. Okay, now changing up the question here, but we're gonna have the same points and everything. We want to find a vector that is orthogonal to the plane that contains the points, and we have the same points. Okay, 1, 2, 3, -2, -3, -4, and 1, 1, 1. Okay, so now instead of a triangle, okay, what you have is a plane. Okay, so you have a plane. Let's draw this here. So we have a plane that contains the points. We have P, Q, and R. All right, and let's say that we again have, we'll just say that this is the same exact vector that we've been finding. This is A, and this is B. Okay. Now, when we found the cross product of these two vectors, A and B, in the last problem, well, that's exactly the same, that's going to be the vector here. That's going to be the vector that is the answer to our problem. Okay? That vector is orthogonal to A and B, and it's going to be pointing out this way. It's going to be pointing out up. Okay? So imagine this plane is kind of like just sitting here like this. Okay, and we're twisting a screwdriver from A to B, so we're going to go like this, and we're loosening the screw so it goes up. All right, and that vector right there is A cross B. Okay, so there, this is another problem that you could be asked. Okay, and it's basically the same exact thing as what we just did, except you're not finding the magnitude of it or dividing it by 2 or anything like that. The cross product is literally your answer. Okay, so something that seems a lot, seems like, okay, how in the world am I going to do this? It's actually just as simple as taking the cross product. Okay, so that's something that I wanted to show you before I end the video. And that being said, that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors in the geometry of space, the explanation video for the uses of the cross product, and the next video in the series. Lastly, if these videos are really helping you, consider supporting me on my Patreon, which I have linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.